Hello, Utkarsh Singh, I'm audible. Please just confirm whether I'm audible or not.
Yes, sir. Yes, sir.
Okay, fine. Okay, so let us start the week number 12 question and answer. So, so today's topic is about your open channel flow. The introduction of the open channel flow will discuss about the question related to the open channel flow. We have the three lectures, and fourth lecture is about the dragon head. So I have the question regarding the all lectures. So let us start with the first, which is very easy question. So first question is the calculate the weighted perimeter of rectangular channel having the top width of 4.5 meter and depth is 3 meter. So you have the top width is your 4.5 meter and depth is 3 meters. So you need to calculate here weighted perimeter. So you have a rectangular channel section like that. So please just try to calculate the weighted perimeter. How you will calculate? Just write your answer. Option A is 10 meter, option B is 15, option C is 12.5 and option D is 10.5. So just please you try to write your answer in the chat box. I'm waiting. So just try to calculate and write your answer please. Very easy question. So are you solving or let me just start? Let me know whether you are solving or not. If not, then I'll just write the answer. Just I'll show how it's. If not
So
solving, then
12.5.
okay. Why 10.5? You are telling option number D, right?
No, sir. C. C. Option number C.
Oh, 12.5. Okay, fine. Okay, let me just calculate. So perimeter is nothing but the addition of the whatever weighted perimeter is here. If the depth of the water is how much? 3 meter. So means the your water weighted the this much periphery of the channel. So you need to add that much, nothing but. So top width is your this width is given 4.5. This if the channel is rectangular, definitely this will also be the 4.5 meter, and this is your 3 meter, and this is your 3 meter. So you can say 3, 3, 6, and 4, 10.5 meter. So option D will be correct here. Hopefully you got it right.
Yes, sir. Yes, sir.
Okay, fine. So let us move with the next question. Very easy question again. So question number 2, the fluid number for a flow in a channel section is 1. You have the fluid number is equal to 1. What type of flow is it? Whether laminar, turbulent, supercritical or the critical. Very easy question. So please within 1 minute just try to write your answer in the chat box. You can write here. For the first option D was correct. Now similarly you can write the your answer here. I have written in the chat box option D, so you can also write like that. Okay, you are telling C option.
Sir, am I the only one in the class?
Yes, you are only one. I don't know why student are not joined today. So okay, don't worry. I'm recording the video. So yes, recording is going on. No problem. So I'll upload the
Okay.
video if someone will see later after uploading. So let
Okay,
us
sir.
move with the next one. So here I have some pictorial representation. What is open channel flow and all. So all these things I have included here. And what is Reynolds number? What is your this uniform and the varied flow? And here is you can see the uniform flow, gradually varied flow, rapid varied flow, then gradually varied like that. And this is uniform flow again. So the everything I have included here. So after once I'll upload this, you can go through. I'll upload the this PDF also, so you can go one by one. And I'll take one extra session. Okay. So this is your float number. Float number is nothing but the V by root G LC. LC is nothing but here is your characteristics length. Remember please. And here you can see if your float number is less than 1 is subcritical or tranquil flow, you know already. And if R is equal to 1, this is critical flow. If R is greater than, then supercritical and rapid flow. So question was about the FR, that is your float number is equal to 1, then it will be the critical flow. Your answer was, I think,
Super
C.
critical flow.
So remember please, the
Okay.
so here option D will be correct.
Okay, sir. Okay.
And again, I want to just show you, yes, the specific energy concept is also given here. What is a specific energy? And in your open channel flow, okay. The next question is the flow characteristics. The flow characteristics of open channel do not change with time at any point. What type of flow is it? Uniform, non-uniform, steady, unsteady. So please, you have 1 minute. Just try to write your answer in the chat box. Question number 3 is try to write your answer.
Sir, please go on. Actually, I do not have any idea about these questions.
Okay, okay, fine, fine. I'll explain also. Don't worry.
Yes, sir. I came just for explanation and
Okay,
theoretical
fine,
purpose.
fine, fine. Okay. So the flow characteristics of a channel do not change with respect to time at a point means if you have, let us suppose you have the channel like that and water is flowing, is the bed of the channel. and this is the water level and water is flowing like that. So the question is, at any point, let us suppose I'm selecting this point P. At this point, the flow characteristics you, or maybe pressure, maybe velocity, right? So let us go with the velocity. So at this point, at the point P1, with respect to time, means at t is equal to, let us suppose 10 am, velocity was 1 meter per second. At t is equal to 10:30 am, v is equal to again 1 meter per second. At t is equal to 11 am, v is equal to again 1 meter per second. So it is not changing with respect to time. So this was the question. The flow characteristics do not change with respect to time at any point. So such type of flow known as your steady flow. Remember please, steady flow. Remember. So option C will be correct here.
Okay.
Uh, Next question. So specific energy of flowing water in rectangular channel of 5 meter width, 2 meter water depth and discharge 10 meter cube per second. So here you need to calculate specific energy, and what is specific energy, just I'll show you. So please just try to calculate. This is very easy, not much. So just I'll show you the formula. Here you can see the specific energy formula. So this is your depth, flow depth, and this is your velocity, and 2, and this is 9.81 acceleration due to gravity. So I'll write here the formula and please just try to calculate, just which is very easy. So here E is equal to specific energy is equal to Y plus V square by 2Z. So in the question you have the width, okay, you have rectangular channel, the width is 5 meter, 2 meter is your depth, 2 meter, discharge is 10 meter cube per second. So now please you just try to, and discharge formula is q is equal to area into velocity. So velocity is nothing but discharge by area, and area is nothing but your b into depth y. So this is your b, this is your y. So please just try to calculate. You have 2-3 minutes. Within 2-3 minutes, please just try to calculate. Very easy. I have told you the formulas. Just please try to calculate. If you're not able to solve, then I'll show you calculation also. So please just try to calculate. So I'll just show you the calculation part also, don't worry. So here your velocity will be, this is 10, 10 is given, and area is 5 into 2. So you will get 1 meter per second. Now you can calculate very easily. E is equal to y is nothing but y is 2
Sir,
plus,
option A.
okay, okay, fine. You are telling option A. Let me just check. And 2 into here is 9.81. So for calculation purpose, I'll take the 10, this one. So 2 plus 1 by 20. So here I'll get 2 point, and this is your 0.5. Yeah, it's okay. And again, the unit will be in meter. Remember, please. So specific energy here, it should be the in meter. Little bit correction. So option A will be correct. Yes, fine. Okay. So now again, the question is here.
Sir, you are at mute.
Oh, sorry, sorry, sorry. Sorry, sorry. Now it is okay.
Yes, sir. Yes, sir.
Yeah. Okay. So I'll explain again. So nothing but we have this formula of a specific energy y plus v square by 2z, and in the question discharge is given already. So
Sir, I
discharge.
solved it. I
Okay,
solved it.
fine.
I solved.
So let us move with the next one.
Yes, sir.
Next is, if the depth of water in an open channel is less than the critical depth, then the flow is known as your torrential flow, tranquil flow, critical flow, turbulent flow. Here is the depth of water in an open channel is less than critical flow. If it is critical flow, and this is channel, let us assume this is your critical flow depth yc, but this is yc, but actually in the open channel you have less depth, means your depth is here somewhere, maybe in the low flow period or high flow period. It's depend on the channel slope and all. So your depth is that much only. So what will be the condition? Whether such type of condition known as your torrential flow, tranquil flow, critical flow, and turbulent flow. So here I have explanation also. One thing is also important. If you not know any question, just please try to Google out. Just try to Google, then you will find out. Because once you will solve this question, then in your mind you have the options and all. So that will be benefit for you.
Okay, sir.
Yes, yes. If you're not aware the question and all, you can just Google, because this is just we are solving here the question, not this is your exam. So you can do these things also here. No problem. If you not know, first try to yourself. If you not know this is based on your honesty, nothing much. So for question 5, what is correct?
Sir, A.
Okay, you are telling option A, torrential flow. Okay. Yes, you are correct. This is such type of flow known as a supercritical also, remember please.
Okay, sir. Fruit number crital and one.
Yes, supercritical flow also known as we have also here discussed above. I was showing the float number things here. You can see supercritical flow known as rapid flow, subcritical flow known as the tranquil flow. So in your option, tranquil flow is already given. Mm, here. this is your subcritical flow. It is possible when the flow is above the critical flow. Remember, please. If the flow depth is above the critical flow, if this is flow depth, then your tranquil flow or subcritical you can say. Right? Or you
Okay,
can
sir.
say this subcritical, and if it is like that, then torrential or the supercritical flow. One thing is
Okay,
very,
sir.
very important. Supercritical flow is for the structure point of view. If suppose here is any structure in the channel, so it is more such type of flow. Supercritical flow will be more dangerous for such type of structure, because such type of flow, supercritical flow or the torrential flow, have more energy than your subcritical flow mostly. So remember, please. So as a name suggests, torrential means something like that, so more dangerous than the torrent. As a name suggests also. So remember that kind of things for this.
Okay, sir.
So here one thing also important. So based on the fluid number, if the fluid number, types of hydraulic jump based on the fluid number, remember please. So such type of
Okay.
questions also very, very important. If your fluid number is in between 1 to 1.7, then the type of jump is undulate and type of water surface is undulating. If it is in between 1.7 to 2.5, the type of jump is weak and a small roller formation. And if it is 2.5 to 4.5, the type of jump is oscillating and water oscillate in random manner.
Okay, sir.
And 4.5 to 9, the flow is
Sir.
type of jump is steady, and if greater than 9 is strong roller and the jump action, and strong is a very rough and the choppy. So remember please. Then
Okay.
now coming, if the depth of water below the spillway and after hydraulic jump are 1 meter and 6 meter respectively, so the head loss here you need to calculate. So depth of water below the spillway and after the hydraulic jump means such type of, so this is your spillway. Like that. So here you have 1 meter and this is your hydraulic jump here is happening after the hydraulic jump. Your flow depth is 6
6.
meter, like that. So this is 1 meter. So you need to calculate the head loss here. Oh, I think yes, head loss. How much head loss is? So this is the question. But for solving this, we have the formulas also. So as you are not aware, so I'll just direct show you the formulas also. So how you will get it? This is the formula. Remember please.
Okay,
The
sir.
formula here. So y1 is nothing but this is your y1 and this is your y2. So based on that, you can calculate very easily.
Okay, sir. Sir, would you please show me the formula again?
Yes, yes. So this is your formula. So please just try to calculate.
So 5.21.
Okay. Yes, 5.28 is coming. Fine. Next question is in an open channel flow for the best efficiency of the rectangular section, the ratio of bottom width to the depth shall be. Here is again the rectangular section. So bottom width and the depth y. So the ratio b by y, what should be the value for best efficiency? Best efficiency you need to calculate. The condition is this. So this is a direct relation after the derivation of your best efficiency for rectangular section. So best efficiency means the idea is within the minimum area maximum flow. Within the minimum area maximum flow. This is the, because efficiency means what? Within low cost you have to get more. So here is
More.
within the less area more discharge, because when you will made this rectangular section, when you will lining, because lining means concreting the wall, this two wall and the bed also, so it will be very costly. So if the area is less, then your cost of the cost of this your digging the your canal and the lining of the canal is will be less. So we'll have two conditions. The discharge will be more and area should be less. So considering these things, we derive after the derivation, the relation will be this one. Remember please. Your width should be two times of the depth. Remember, right?
Okay,
This is
okay.
your rectangular channel. Like that. This is your B and this is your Y. So maybe this is your, yeah, next one. Question number 9. In a rectangular channel, the depth of flow is 1.6 meter. Depth of flow here you have 1.6 meter. The specific energy at that section 2.7 meter. Then the flow condition you need to calculate here. You have the specific energy is 2.7 meter and the flow depth is 1.6 meter. So you need to tell here the flow condition. Flow condition will be whether it is critical, subcritical, supercritical. So for your this, how you will decide based on your float number. So using this, the float number formula you know already, V by root G Y. If it is rectangular flow, you need to take Y, that is flow depth. So somehow you need to calculate flow depth. You already know G, you already know. Somehow you need to calculate the V. So based on the E formula, you need to calculate the V, then put in this and try to calculate the FR, and based on the FR value, you need to tell the critical, subcritical and supercritical. So this question will take time. So you have the 3 minute or 5 minute you can take also, because you need to calculate E also here. So based on the E, you need to calculate first velocity, because in the formula of your specific energy, you have the velocity formula. Velocity, then from here you can calculate the velocity, put here in the code number, then try to calculate. Yes. You take
Okay,
5 minutes
sir.
also. Hello, yes, hopefully I am audible to you. So we have solved already the 8 questions. So yeah, okay, fine. So we have already solved the 8 questions. So we are solving the question number 9. So please just try to solve. This is your related to whether the flow is critical, subcritical and supercritical. So you will try to tell based on the flow number. You have the data, specific energy 2.7 and your flow depth is 1.6. So please just based on this, you just try to calculate. Yeah, Utkarsh is telling option C. Oh no no. This was the for previous. Okay, for this you please both you try to just calculate. Yes, the yes is telling option A, okay? So you are telling the critical flow means if R is coming 1.
Sir, option number C.
Okay, you are telling the supercritical. Let me just check whether. Okay, so E is equal to nothing but I have told you in the previous question, Y is equal to V square by 2Z. So E is 2.7, Y is given plus V square you need to calculate, and I'll take here the 10 at the place of 9.81. So this will give you 1.1, 2.7 minus 1.6, V square by 20. So this is your 1.1 into 20 is equal to V square. So V is nothing but square root of, so 22. This is your V values, and FR is nothing but root 22 divided by root Z is 10. I'll take also here, and this is your 1.6. So this is your 22, and this is your root 16. Means this is your greater than 1. That means greater than 1. After the calculation, you will get greater than 1. So definitely,
Yes. So definitely,
if your FR
if
is
your
greater than
FR is
1,
greater than 1,
so this will be your,
so this will be your,
hello?
no? Yes, sir.
Yeah. Now it is okay. Oh, I'm getting the echo sound. I don't know why. Problem. Hello? Yeah, now it is okay. Hello? Hello? Yeah. Now it is okay. So it will be greater than 1 means what? Your subcritical, if it is equal to 1, then your critical. If it is your FR is less than 1, then supercritical. So here is your greater than 1 means the subcritical condition. So hopefully B option will be correct. Let me just, yeah, it is coming the supercritical flow. So is there any mistake in the calculation? No, I think I'm writing here something wrong. The condition I'm writing, I think, wrong. I'll just show you. Yes. If it is greater than 1, then the supercritical. Less than 1, then subcritical. Remember. Sorry. Sorry for the mistake. It's a big mistake. Yes. So this is your supercritical, and this is your subcritical. So definitely here your option C will be correct. Okay, fine. Hopefully you guys got it.
Yes, sir.
Okay, fine. Let us
Okay,
move
fine.
with the
Let us
next one.
move with the next one.
Question number 10. A 1.2-meter wide rectangular channel of bed slope is this 0.0004 and the Manning's coefficient 0.01, carrying the discharge 5 meter cube per second. The normal depth of the channel is. 0.5, 1, 0.25 or 1.25. So here you have the rectangular channel again. Slope you have 0004. Discharge is your, and Manning's coefficient is 0.1, and width is wide, means here I'll write the B value is 1.2 meter. So the normal depth you need to calculate, means the depth you need to calculate here. So velocity formula, what will be the velocity formula? Okay, please first try to calculate, then I'll write you. 1 by n, or you can search the formula also if you not know. So R is nothing but your hydraulic radius, weighted area by weighted perimeter. So now you can calculate very easily. But here is, yes, okay, fine. So for this question, you both please have the 5 minute, because this is a calculative type. So just try to calculate this. So yes, you are telling the option C, that is 0.25. Okay. So I'm waiting for the Oscar's answer. Okay. So because you are telling option A is correct. Okay, fine. So let me just write the answer. So area by perimeter. Area is nothing but by. Here you can write wide rectangular channel means b plus the perimeter will be b plus 2y. So here you can, for wide rectangular channel means your b is much greater than 10. So for here you can write b only. So area by p for wide rectangular channel, b by by b, so it will be the y. So you can replace this. Velocity is 1 by n, y to the power 2 by 3, s to the power 1 by 2. So this is possible only for the wide rectangular channel, remember please. So your n value is, your velocity is given, discharge is given, okay. Area into velocity, so velocity is nothing but discharge by area. So discharge will be 0.5, area will be b into y. So here you can put 0.5 by, and b is also given in the question. B is 1.2, 1.2, 1 by 0 1, and y is equal to, you need to calculate 2 by 3, s is given already in the question. So after calculation, what you will get, let me just show you. Okay, after calculation you will get 0.5. 0.5. Yes, option A is correct. After the calculation, maybe the calculation mistake, you can go and here the formula is direct taking the discharge, remember please, but I am right. Here I have written the formula in terms of only the velocity. So remember these things also.
Also,
So after
so
calculation,
after calculation,
you will get
you will
0.5.
get 0.5. Okay.
So I have another
So I have another
question.
question.
Again, echo is coming. I don't know
Again,
why.
echo is coming. I don't know.
Hello. Oh, I'm just checking. Sometimes the echo is, I don't know why it is coming. No, yes, you can close or you can also write in the chat box, but today I'm facing only. Okay. So now we are not facing, right? Okay, okay. I think when you are open, then we are facing. I think you can close, yes. Okay, so let us move with the another set of questions. We have already solved the 10 questions. The sum of the component of the pressure and wall shear force in the direction normal to the flow is called drag, friction, lift, or bluff. So you have four options. Sum of the component of the pressure, remember please, sum of the component of pressure and wall shear force in the direction of normal to the flow is called, whether it is drag, friction, lift, and bluff. So we see from the lecture number 4. So if you not know, please just try to Google and just see the figure also. When you will see the figure, what I am, the question is telling, where the what is the sum component of the pressure and shear force and the direction normal to the flow. Some pictorial representation also you try to see in your search. Definitely you will able to give the correct answer. If you not know, then you know there is no issue. Okay. So Utkarsh is telling C, lift. Okay, fine. And what about yes? Very easy question. Okay. So definitely, if it is normal to the direction of the flow, definitely it will be the lift. So definition here is also given. What is drag force? So drag refers to the force acting parallel to the flow direction. Remember, this is parallel to the flow direction, and lift is the normal to the flow direction. Next question is, the manufacturer of a car reduced the drag coefficient of the car from 0.38 to 0.33 as a result of some modification in its shape and design. Okay. If on average the aerodynamic drag account for 20% of the fuel consumption, the percentage reduction in the fuel consumption of the car due to reducing the drag coefficient is. So this is your analytical type questions. This is not based on your the formula and all. So this is the mind just to think on the question. Just read the question and think the question. Very very important question. Just think and try to solve. There is not much. So you can take the 5 minutes for this also. Option D, 2.6. Okay. So let me just show you my answer. So here is the conditions. Initially the drag coefficient was 0.38, but after modify in your the shape and design of anything, or maybe the car you can think. Yes, car. So the drag coefficient is reduces after the shape modification, and is reduces up to 0.33. So if on an average the aerodynamic drag account 20% of the fuel consumption, so if your fuel, think on that, if it is 100-liter fuel, so you, due to the drag, 20-liter, you can assume here 20-liter consumed by your drag only. So if it is drag is reducing, means this value, this 20-liter may be reduced by 16-liter or 15-liter or something like, because drag is reducing, your fuel will be, fuel also reduce, the fuel consumption due to drag also will also reduce. So if here, in the 100-liter, if your car was running, let us suppose 200 kilometer, just this is assumption. So here your car will run 200 plus kilometer. So this was the question. So just simple calculation here, you can just think on that. So yes, option D is correct. Yeah, okay. But the drag reduce is 0.2. 0.38 minus 0.33. So this is your 5. 0.05. The drag coefficient you reduces 0.05. So please just I'll take here the 5-minute break. Okay, so fuel consumption was your 22%, that is your 20%. So after the calculation you will get, that is your 0.05 drag coefficient is reducing. So with respect to how much reducing, with respect to your that is the initial one, 0.38. So here is just the same calculation is your, the minus 0.05 with respect to 0.38 into 100. So percentage reduction, and your, when you will calculate with your the fuel, so you will get, because your fuel is 20%, remember please. So just we calculate whatever will calculation will do here based on your fuel consumption due to the drag, not the all fuel consumption. So this was the main thing. So next question is, okay, so I'll take the 5-minute break here. So you can solve the question number 3. Yeah. Yes. Hello? Hello, yes, I'm audible. I have connected with another device. So whether I'm audible or not, please just confirm. Then I'll move with the question number three. Hello? Okay, let me just connect myself. Hello, yes, I'm audible, please. Okay, 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 fine. Thank you. So let us move with the next question. Question number three. So if the flow depth remain constant in an open channel flow, the flow is called uniform flow, steady flow, varied flow, unsteady flow. So please just try to write your answer in the chat box. I'm waiting for question number three. Very easy question. Yes. The flow depth is will remain constant. Option A, you are telling. Uniform flow. Okay, fine. Yes, you are correct. Uniform flow. But maybe few student, for few student, let me just put in the questions. So if the flow depth remain constant in open channel flow, so the flow is called the uniform. Yes. Remain constant means if the flow depth here is 1 meter, so everywhere flow is 1 meter. Here also 1 meter, here also 1 meter. But the question is incomplete here. The flow depth remain constant with respect to space. Then the question is completed. So in that case, we will go with the uniform. Remember this. Next question is, so you have water flow in rectangular open channel of width 5 meter at a rate of 7.5 meter cube per second.
The critical depth for this flow is 0.54 meters, 0.25 meters, 0.61 meters, 0.96 meters. So please just check that. The critical flow depth. So for this question, you have 3 minutes. So within 3 minutes, you just write it. Okay. So let me just, okay. So rectangular open channel you have. Width is 5 meters and the flow rate is given 7.5 meters per second and the critical flow depth YC you need to calculate here. So the for critical flow depth you have one relation is whereby so Q here is nothing but for rectangular channel, remember this. I'll just show you. So from here you can calculate your Q values. This is 7.5 and B is 5. So it will come around 1.3, 1.5, and you can put here 1.5 square divided by 9.81 power 1 by 3. So you will get your final answer. So it is how much? Have you calculated or not? Okay. So your final answer will be, let me just calculate, 1.5 square. So 1.5 square divided by 9.81 power 0. So it is exactly coming, not exactly, 0.61215 it is coming. So to two decimal, option C will be correct. So remember this. Or you can write direct formula also. Yeah. How it is? Direct formula, as I have told you, yc is equal to q square by g to the power 1 by 3. So your q is nothing but capital Q by b. So you can put yc is equal to uh, q by b square divided by g to the power 1 by 3. So finally you will get q square divided by gb square power 1 by 3. So this is the formula. The next question is, in case of open channel uniform flow, the fractional force is balanced by pressure force, gravitational force, momentum force, both B and C. In open channel or uniform flow, the fractional force is balanced by pressure force, gravitational force, momentum force, both B and C. So within 2 minutes, please just try to write your answer in the chat box for question number 5. So this is very conceptual question, question number 5. So please just try to calculate. Just think on that. Not here, the calculation is not involved. Just think on it. Here is the frictional force means your the shear force, the acting on the bed. Let me explain. So here in the open channel, just think on that. The flow is uniform. Uniform flow means your velocity is not changing. Velocity not changing, right? So it means this is your open channel with uniform flow. So whatever the velocity is here, the similar velocity is here at a particular time. So let us suppose velocity is x, here is also velocity is x at both places, right? So frictional force, which is exerted here on the bed, the frictional force is, and this, and the slope of the bed, just think on that, theta. So for the your gravitational force, you have the two component, one in the downward direction, another in this direction. Momentum force here will not exist because of flow is momentum is what the velocity is changing. Here velocity is not changing, so this is not the case here. And the pressure force is in your vertical direction, but we are discussing about here the frictional force that is along to the bed. So definitely you have only one option, the gravitational force. So in uniform flow, open channel uniform flow, your gravitational force balance the frictional force. Remember. So explanation is given very well here. So you can go one by one. So I'll read just the conclusion part. In uniform open channel flow, the gravitational force acting downslope, yes, is the driving force. The frictional force exerted by the channel boundary is the resisting force. Okay. These two forces balance each other, maintaining the uniformity of the flow. Since momentum force involve change in the velocity, which do not occur in the uniform flow because the flow is uniform, so no, not velocity is changing, so momentum force will not occur. And pressure force primarily act perpendicular to the flow direction, and they are not responsible for this force balance. So therefore, the frictional force is balanced only by the gravitational force and not by the momentum of the pressure force. So whatever I was discussing, the same thing here. And here is given why momentum force not directly responsible because of the momentum force as related to the change in velocity in the fluid as dedicated by the Newton's second law of motion. However, in the uniform flow, by definition, the velocity remain constant along the length of the channel. So there are no change in the velocity or direction. So there are no additional momentum force acting on to the driving or resist the flow. Therefore, the momentum force do not directly contribute to the balance of force in this case. The next one, why pressure force is not directly responsible? Because in open channel flow, the primary pressure force is hydrostatic pressure acting vertically. The uniform flow, the pressure distribution is mainly hydrostatic and meaning it acts perpendicular to the flow direction vertically and does not contribute significantly to the force in the downslope direction. The longitudinal pressure force cancel out along the channel length in the uniform flow. So pressure force do not play significant role in the driving the flow downstream. So remember, please, these are these condition for the uniform. Remember, condition is given here. Uniform flow, not non-uniform. You cannot think like that. Next question, question number 6. What are the effects on the body with mass immersed in fluid which is under motion? What are the effect on body with mass immersed in fluid which is under motion? The lift and drag, drag and friction, lift and friction, friction and shear. Just think on that and try to write your answer in the chat box. So you have 2-3 minutes for this question. So please just think on that. Okay, so okay, let me just show you the answer for this question. So body with mass immersed in the fluid under motion. Okay. Effect on the body with mass immersed in the fluid which is under motion. So let us suppose fluid is moving. Fluid is moving and here you have put some mass immersed somehow. So what will be the effect on that? So definitely it will be the drag and lift. Option A will be correct. Here explanation is also given. Lift or drag you can say or drag and lift. But explanation let me just read why. When the body with a mass is immersed in fluid that is in motion, it experiences two primary forces, lift and drag. Lift force, what is the force acting perpendicular direction to the fluid flow caused by the pressure difference on different parts of the body. Drag is the force acting parallel to the direction of flow which oppose the motion of the body through the fluid. So what is friction refers to the surface interaction between the fluid and the body which contribute to the drag. However, the friction alone does not account for all effect on the body in the motion through the fluid, especially the lift force, which is essential in many fluid motion scenarios. Example, the airplanes, boat, and etc. Lift rises due to the pressure difference and in a critical part of the force system. Remember? So here is explanation is given. You can go one by one. So for conclusion part, I'll just read. Lift and drags are the most comprehensive pair of the force acting on the body in fluid under motion. Lift describe the force normal to the flow and drag describe the force parallel to the flow, both of which fully describe the effect on the body. Next question, very important. Yes. Question number 7. A hydraulic jump of flow depth are 0.4 meter and 3.6 meter at upstream and the downstream respectively. The channel is wide rectangular. Remember, here also the condition is given wide rectangular. Find the discharge per unit width. Here you need to calculate discharge per unit width. You need to calculate the small q, which is defined like discharge per unit width. So you need to calculate. You have the data like that. So for this question, I'll give you the 5 minute. So within 5 minutes, please just try to calculate. Okay, so let me just discuss. So here you have the value of hydraulic jump flow depth. So let us suppose you have y1 is equal to, in the question is given, not suppose 4 meter, 0.4 meter, and y2 is given 3.6 meter upstream and the downstream respectively. So meaning of this, uh, let us suppose one case of the spill. So let us suppose here hydraulic jump is coming. So upstream means here before the hydraulic jump is 0.4 meter and after the hydraulic jump is 3.6 meters. So this is your downstream, this is your hydraulic jump, and this is your upstream. So the question is given like that. The channel is wide rectangular. Find the discharge per unit width. You need to calculate this value. And G is, you need to consider here 9.81 meter per second square. So the formula, direct formula for this is, you can follow this one. Q is equal to root under G y1 y2 divided by 2 is equal to 5.3 meter square per second. But you can think in the different way also how you will proceed with this. Per unit width. So per unit width means here the B value is already unit is telling, so you can assume here 1. So now you can calculate very easily. So you know the float number is nothing but P by G into Y. So let us suppose I am calculating at the place of 1. If it is 1, then it is 5. So if you know the velocity, discharge is equal to nothing but area into velocity. Area is B into Y1 if you are calculating at the place of Y, B into Y1 into velocity Y1. So Q is equal to. So B nothing but you need to calculate Q by B. So Y1 V1. So Y1 you already know you need to calculate V1. For calculating the V1, you have to calculate FR1. So how you will calculate FR1? Nothing but the formula for this hydraulic jump for rectangular flow is Y1 by Y2 is equal to 1 by 2. Very famous formula. Okay, we have the another question based on this. At that place, I'll explain it. So without delaying, let us move on the next question. So next question is question number 8. For a given discharge in a horizontal frictionless channel, two depth may have the same specific force. Remember, please here, the question is talking about a specific force. These two depths are known as specific depth, secant depth, alternate depth, normal depth. So please just think on that and write your answer within 1 minute or 2 minutes you can take for this question. Okay. So the answer for this question is, if it is on specific force, remember please it is the second depth. If it is on specific energy, if the question was like that, for a given discharge horizontal frictionless channel, the two depth may have the same specific energy at the place of force, then we will go with the alternate depth. But here is the specific force is given, you need to go with the this second depth. Here option B will be correct. So I can read this. The depth with the same specific force are known as the second depth, and the depth with the same specific energy is known as alternate depth. The next question is very important. A 4-meter wide rectangular channel convey 15 cubic meter cube per second of water depth 2.5 meter, 2.5 meter. Calculate the critical energy. Calculate the critical energy for this 4-meter wide rectangular channel. There is the 4 meter. 4-meter wide rectangular channel. Calculate the critical energy. So how you will calculate? So critical energy is nothing but critical depth plus V square by 2. So I think previously I have discussed about this also. Here we have some conceptual. I was initially, the beginning, I was telling about that. Yes, here you can see. Yes, velocity will also the critical remember this. And the critical velocity is this. So I'll show you how it is. I just show you. Here critical velocity will also be there. So critical velocity is nothing but Fr is equal to, when you will write Vc by root GYC, means equal to 1, because at the critical depth. So Vc is equal to root GYC. Once you will put here, right, EC is equal to YC plus VC is equal to, so VC square is equal to what? GYC. So here GYC by 2. G will be cancelled out. So 1 YC and YC by 2 means 3 by 2 YC. So for critical depth, for rectangular channel, your 3 by 2 YC. Because this formula for this of road number is your for rectangular channel, remember this. Okay. So what is YC? Again, so YC is nothing but Q square by G to the power 1 by 2. So what is Q? Q is nothing but your capital Q divided by D. Capital Q is here, capital Q is your 15 and B is 4. So you can calculate very easily. Let me just calculate. Your 15 divided by 4 is nothing but 3.75 meter square per second. And here you need to put 3.75 square divided by 9.81 power 1 by 3 divided by 9.81, no, sorry, square is equal to 14.06 divided by 9.81, that was divided power 0.333. So it is YC is 1.127. Now you can calculate and you can write 1.5 YC. EC is equal to, so multiply with the 1.5. So 1.7, 1.69 it is coming. 1.69 meter. So option C will be correct here, please. Remember always. Okay. The next question. For a mild slope channel is flowed by a steep slope channel. The mild slope channel is followed by the steep channel. Means mild slope is like that, followed by the steep. Okay, here is this intersection. The profile of gradually varied flow in the channel. The profile of gradually GVF in the channel. So here is the mild slope. So in the mild slope, this is your normal flow and this is your critical flow in case of the mild. This is showing the critical, this is showing the normal. But in the steep channel, this will be the your not normal and this will be the critical. Which one? I think. Okay. So now here you just think the which profile will fall. So always remember the flow will go from normal to normal. If flow is coming from here normal, so it will go in the next slope normal. So like that. Flow will be formed like that. So it is, remember, so this was your critical, like CDL means critical line, and this is yours showing the normal line. And in the steep slope like that. So here the M2 will form and here S2 will form. Remember. So M2 S2 combination will be formed. So M2 S2. Option D will be correct. Next question. For a pipe of radius r flowing half full under the action of gravity, the hydraulic depth is hydraulic depth. Pipe of radius r half full means behaving like open channel. So hydraulic depth. So what will be the hydraulic depth? So hydraulic depth is nothing but A by T, area by problem. What is the area? pi r square, full circle area divided by 2 half circle area divided by T top width. Top width is nothing but your r, half is r and half is r. So 2r. So it will cancel out. So pi by not cancel out. So this is 2 and this will be divided by 2. So r will be cancelled out. So pi r by 4. This will be the correct answer. D option will be the correct here. Next one. A water discharge into a rectangular horizontal channel from a sluice gate and undergoes a hydraulic jump. Okay. The channel is 25-meter wide, flow depth, and the flow depth and the velocity before the jump. That is y1 is given 2 meter and 9 meter per second is given v1. The flow depth after the jump. You need to calculate y2. So y2 by y1 relation I was discussing previously. So this is your relation. This is your relation. So y2 divided by y1 is equal to 1 by 2 minus 1 plus square root of 1 plus 8 fr1 square. Remember please, this is the if like y2 is equal to y1 by 2 minus 1. I'll show you that. I'll just tell you the trick. If in after the equal to, that is the right hand side is y1, then fr also will be the 1. If you will write this formula like that, y1 is equal to y2 by 2, then inside the, here is the plus, then inside the under root you will write fr2. Remember, if it is one left inside, you just remember for this is a rectangular channel, and after the calculation you will get 4.83. Similar kind of question is given. The pre-jump flow number for a perpendicular flow in the horizontal rectangular channel is 8, the ratio of the second depth. The pre-jump means flow number means FR1 is given. If FR1 is given, so what you will write? You will write the formula like Y2 by Y1 is equal to 1 by 2 minus 1 plus, not like that, 1 by 2 minus 1 plus root under 1 plus 8, 8 FR1 square. And after putting the your uh, 8 value here, you will get Y2 by Y1. So second depth is telling, so y1 by y2. When we will calculate, we will get the final answer. So here it is given. Similar things, you need to calculate the flow rate. The wide rectangular channel is given, discharge, and the channel bed slope is given. Manning's roughness coefficient and slope is given. Manning's formula you need to apply here. And you will check after calculating your normal depth from the Manning's formula. From the Manning's formula, after calculating the normal depth, you will calculate the critical depth, and you will check whether your critical depth is greater than or less than for your normal depth. After getting the condition, so here is after the calculation, you will get your critical depth is greater than normal depth. Your steep slope will be there. Next one, calculate the terminal velocity of 1 mm diameter rolling falling still air at standard atmospheric pressure and temperature 20 degree. Drag coefficient is given and the density of water is given, density of air is given. So terminal velocity you need to calculate. The formula for the terminal velocity, you know already, it is given here, and after the calculation you will get 0.0 4.02. So B option will be correct. So that's all for today. So tomorrow I have also class, extra session class for 2 hours. So please, if anyone want to join, can come. Or otherwise, I'll record the video and upload on YouTube channel. So thank you. Thank you all. So let me just stop.